What's up, guys? This video is going to be on the Pulleys system and just pulleys in general. So let's just get straight away right into this. So this pulley system is referred to as Atwood's machine right here on the left. If the mass on the left, so this one is going to be 20 kilograms, and the mass on the right is 30 kilograms, so this one's heavier. What is the net acceleration on the system? So basically, when we are working with pulleys, we see that these guys are going to be working against each other. So we're going to want to find the net force, because essentially on the right side, we have 30 times the acceleration is just gravity, and then this one is also just gravity. So it's going to be 30 times 9.8, which is just going to be equal to the force on the right side is going to be equal to 294, right? This is done by 30 times 9.8, and 9.8 is gravity, right? And then force on the left side is going to be equal to 20 times 9.8, which is going to be 196 newtons. So these are both in newtons. Now, they're working in opposite directions. So what are we going to do? We're just going to subtract them from each other, because they are in opposite directions and they're not adding on to each other. They're conflicting forces. So our total net force is just going to be 98 newtons. So obviously, since this one is heavier and the acceleration are the same on both sides, it's going to be, this one will eventually be going down, and actually this 20 will be brought up because of the conflicting forces. So it's 98 newtons going in this direction. So that is our net force. We're looking for the net acceleration. So we have our net force, which is going to be equal to mass times net acceleration. Now, what is the net acceleration on the system? The total mass is going to be 50. There's 50 kilograms moving, right? So this 30 is going down. Just because they're conflicting doesn't mean we just don't acknowledge the 20. It's 30 plus the 20, which is the 50. So there's 50 kilograms in total in this pulley system, multiplied by our net acceleration. So we just need to isolate the acceleration by dividing, and we get acceleration is equal to 98 divided by 50, which is going to be 1.96 meters a second squared. And that right here is our answer. In this problem, if the small mass is 20 kilograms, so this one's the small one, 20, and the large mass is 45 kilograms, and the coefficient of static friction is 0.7, right? So mu is equal to 0.7. What is the net acceleration on the large mass? So net acceleration on the large mass. So this question can be kind of confusing because of the wording, but you'll see that you kind of just want to ignore the wording. So essentially in this question, we will be having 45 is just falling, right? So it's 45 times 9.8, which is going to be 441 newtons going downward. So that is the force of the big mass, right? So we can just call it force of B, force of the big mass. Now, because there is 441 newtons going this way and it's connected on the pulley, there's 441 newtons basically going like this, right? So there's 441 newtons pulling on that small box. So essentially what we need to do is we need to find the frictional force that is resisting on the small box. So we have to do 20 times 9.8 to find the normal force, right? The normal force goes upwards, which is reciprocating the downward force. So those are always equal. And so our normal, or not always, but in this case it is equal. So the normal force is going to be 20 times 9.8, which will essentially just be 196 newtons. And so now we need to multiply that normal force by our static friction, or mu, which is 0.7, which means our frictional force will be 137.2 newtons. So frictional force. Okay, so that frictional force is going to the left. Going to the right is our big force right here, our 441. So we have to subtract 441 by the 137.2, and that is going to get us 303.8 newtons. So this right here is our net force, and that's going to be MA, right? So it says the large mass, so you want to put 45 as the mass, right? That's what you want to do. But like the last pulley problem, this 45 is dragging this 20 as well. So no matter what, we're adding those masses because they're going together, because they're connected by a rope. So it's 65 as the mass times, we are solving for the acceleration, so we want to isolate for that acceleration, and we will be getting negative 4.67 meters a second squared. Only reason why it's negative in this problem is because we're going down. That's it. So it's just a directionality thing. All right, so in this question, we have an inclined plane. And if mass 1 is 20 kilograms, so this one is mass 1, 20 kilograms. Mass 2 is 30 kilograms. On a frictionless surface, and the angle of the inclined plane is 40 degrees, what is the magnitude of the acceleration on mass 1? Okay, so again, it's same. Acceleration on mass 1. But now we know it doesn't matter really what mass it is because they're both connected. So essentially what's going on here is we still have our mass going down right here. So 30 times 9.8. 30 times 9.8 is just going to be 294 newtons going in the downward direction. So that means that, right, because this is all connected, there's 294 newtons pulling upwards on this mass 1. Now, there's no friction, but just due to gravity, this mass right here wants to slide down the inclined plane, right? So we need to figure out this force right here that's causing it to want to slide down. Now, how do we find that? If you guys watch the inclined plane video, it is simply just going to be mg, right? So 20 times 9.8, and then multiplied by sine of 40 degrees, okay? If you're doing this and you're getting a different answer, this answer should equal to 125.986. If you're not getting that, you might have your 40 in radians and you want to switch that into degrees. If you don't know what's going on here, if you don't know why I'm doing mg times sine and then the angle, then you're going to watch my inclined planes video, and that will make this problem make more sense. So this is going to be the force that is going down, pulling down on mass 1. And essentially what we're going to want to do is we're going to want to find the net force. So these are conflicting forces. Resistance is happening here, so we're going to want to subtract, which will give us a net force of 168.01 newtons, right, approximately. Now, we have this net force of 168.01, basically just 168, which is equal to, we're going to want to add the masses together, right, because they're connected, 50 A, divide by 50, divide by 50, and our acceleration is going to be equal to 3.36 meters a second squared. And that is going to be our answer for acceleration. Now, what if this problem had friction? So let's say that mu is equal to 0.85. So if mu is equal to 0.85, basically what's happening in this problem is this 30 is 294 newtons, right? We still have this 125.986 trying to resist the actual force that's happening, right? This 294 newtons. So friction, because this block is still moving up because this force is so powerful, it's still moving up, which means that even though it's trying to go down, the frictional force is opposing the actual movement, right? Because friction only happens if something is in motion. So the motion is still going upwards, which means our friction is going downwards. So what we're going to have to do is, to find friction, it's first we find a normal force, which is going to be mg times cosine of theta, which is 40 degrees, right? And then that's going to be equal to 150.145 approximately. And that is our normal force, so we're going to have to multiply that by our mu, 0.85, to find our frictional force. Oh, shoot, sorry. Multiplied by our mu to find our frictional force, which is equal to 127.623. So what we're going to have to do is we're going to have to subtract this by that 127.623. Which is equal to 40.387 newtons approximately, right? So this is our net force now that we have friction going on. So this is equal to mass, which is 20 plus 30, 50, times acceleration. Isolate for acceleration by dividing 50 on both sides. And acceleration is going to be equal to 0.81 approximately if you round up. And that is our acceleration if there was friction on this problem. Let's go to the next one. Okay, this question is not really so much about pulleys, but this is going to be an understanding challenge question for your inclined planes and just kind of what we learned about in that last problem. So a person has already accelerated a 40 kilogram box, right? So this is 40 kilograms up an incline ramp. And once in motion, the person applies a constant force on the box so that it travels up the ramp at a constant velocity. The coefficient of friction between the box and the ramp is 0.75. How much force is being applied to the box by the person? So essentially what is going on here is when you start pushing something up, like if you've ever pushed something up a ramp, it's very hard at the start. And then once you get it moving, then it becomes a lot easier. And now you're just like, you're just chilling. You're just moving it up, right? So the reason why it's so hard at the start is because there's no motion and there's friction working against your initial motion. Once you can start pushing hard enough for you to equal friction, that's when it becomes easier and you can just push at a constant velocity. So that's what this is asking. When you hit a constant velocity, how much force do you have to apply to hit that? It's when it's equal to the frictional force. So now that you know that, this problem becomes very easy because all we need to do is basically find frictional force. But it's not just frictional force, actually, I'm sorry, because essentially what's happening, and with this mass, if the person wasn't here, this box would want to naturally move down. So you're also working against gravity. So you're working against gravity plus frictional force once it's in motion. So that's what we need to solve for. We need to find the force moving the box downward due to gravity and the force resisting the motion upward, which is friction. And we add these two forces right here together, and that's going to be equal to the amount that the person is pushing upwards. Find normal force first, which is mg. So mg multiplied by cosine of 20 degrees. And this is going to be equal to 368.36. So this is our normal force. Now, we need to multiply this normal force by mu, which is right here, to find frictional force, which is equal to 276.27 newtons. So gravitational force is going to be 40 times 9.8 mg again, right? But this time it's just sine of 20, which is going to be equal to 134.072. So we just need to add these bad boys together, and that is going to get us approximately 410 newtons. And that is the total force going down, which means that is the amount of force that the person has to apply for there to be a constant velocity and a constant force happening. So that was our challenge question, but not really related to pulleys. But I hope you guys enjoyed this video. See you in the next one.